This podcast is about naming alkanes, which are the simplest of the organic groups. The rules for naming alkanes also apply to the other functional groups in organic with some slight modifications. So let's take this first compound. It is a hydrocarbon, that is, it's got hydrogens and carbons in it. And what you look for is the longest chain. So you start counting from one end of the chain to the other. So notice there are 4 carbons in a row here. Now we could have counted from the other direction, starting at the carbon at the bottom there and going up towards the carbon at the top. And we'll talk about the reasons behind that here in a little bit. Notice that there's 1 carbon then that's not part of the continuous chain, and we will take care of that carbon as well here. There are 4 carbons in the longest chain, so the base name for this compound is going to be butane. Now, when there are alkane groups that are attached to a long chain, like the CH3 group that you saw attached in the previous slide, they are named by dropping the ANE at the end and simply adding YL. So a CH3 group, normally CH4 is methane, CH3 then becomes methyl, a 2-carbon group becomes an ethyl group, a 3-carbon group becomes a propyl group, and a 4-carbon group becomes a butyl group. So in our previous structure there, the little group that was attached that was not part of the 4 carbons in the chain, that would be called a methyl group. So far we have the base of that compound is butane because there's 4 carbons, and we have a methyl group attached to the 4 carbons in the chain. Now, we also need to indicate where that methyl group is located, so on which carbon. And we had the chain numbered before, 1, 2, 3, 4. So we actually want to indicate that that methyl group then is located on carbon number 2. So we're going to actually call this 2-methyl butane. So butane is the base, 4 carbons. The methyl group is located on the 2nd carbon, and the 2 indicates the position there. So here it is, the name, 2-methyl butane. So 4 carbons in a row, butane. 2-methyl indicates the location of the methyl group. And then if we had multiple groups attached to this chain, we would then put them in alphabetical order. So if we had an ethyl group here also attached to a chain, that of course would come before methyl. So they're actually put in alphabetical order. If we have multiple groups, like we have 2 methyl groups on the same chain, then we use prefixes to indicate that there's 2 of them. So that would be dimethyl. So the 2 in the front there indicates the position on the carbon chain of the methyl group. The methyl part indicates the part in blue, the circled group there, the methyl group. And then butane refers to the fact that there are 4 carbons in the chain. So let's practice this. Let's take this compound. This again is a hydrocarbon. It does have a Cl on here, so we can actually name that Cl attached there as well. So let us start by counting the carbons here. So we're going to count the longest chain. And sometimes this takes a little practice. You count through and you don't necessarily get the longest chain, so you go back through and you count again. So we have 9 carbons here. So that means the base name of the compound is going to be nonane. And then notice there are 2 CH3 groups, and there's also a Cl group there that is not part of the longest chain. So again, when we have alkane groups and they are attached to the longest chain, like the 2 CH3s that you see there, we drop the ANE and we add YL. So those 2 that are in blue, each one of those would be called a methyl group. And then Cl, and this applies to all of the halogens, so this would be fluorine, chlorine, bromine, and iodine. You simply drop the INE ending and put O there in place of it. Now, the positions of each of the groups then are specified by number. We said this before. And you want to number the chain in such a way that it gives all of the groups attached the lowest possible numbers. So it looks like most of those extra groups are attached more to the left end of this chain, so therefore we're going to start counting 1 through 9 rather than counting 9 through 1. Now, we could have gone in the other direction and started at the right, started at the right with 9 and then went all the way down to 1 there at the bottom, but you want to give the groups the lowest possible numbers there. So, the location and name of each substituent then is followed by the root alkane name, and then the substituents are listed in alphabetical order. So we have a methyl group, but we have 2 of them, so that's dimethyl, and then we have a chloro group. So when we name this compound, 2-chloro indicates the position of the chlorine on the second carbon in the chain. 3,6-dimethyl indicates the 2 methyl groups located on carbon number 3 and carbon number 6, and then nonane indicates that there are 9 carbons in the chain. So again, as far as naming alkanes, you want to find the longest possible chain, then you want to name all of the groups that are attached to that chain. The longest possible chain then determines the base root name for the compound.